Hello, everybody. This is supposed to say March 27. All right, so this is going to be an easier assignment than many of them have been lately. So we're going to learn to name covalent compounds. They're very different than ionic compounds, and you'll see by the naming why we have to do it. But the key idea here is there are so many charges possible with covalent elements in a covalent bond. And all these different charges are really partial charges, right? Partial charges. And so the name that has come to be what they're called is our oxidation numbers. All right, instead of charges, because they're partial charges, they're just given the name oxidation numbers so you don't confuse them. All right, so there are so many possible. Roman numerals don't work like they would be with transition metals. So the way we handle covalent is to use Greek prefixes. All right, so let's go over and look. Sometimes even metalloids use this naming convention if there are multiple compounds that can occur with the same two elements. For example, antimony tribromide. Antimony is Sb. Tribromide means 3 bromine atoms. So that name tells you there's 1 antimony atom and 3 bromine atoms. All right? Or disilicon hexabromide, di in the Greek prefixes means 2. All right? Disilicon hexabromide, hexa means 6. All right? So there would be 6 bromines. Okay? Or diboron monosilicide would mean 2 borons, and a silicide would be Si, silicon. All right? So B2Si. Now, hexaboron would mean boron with 6 after it. Monosilicide would be Si1. Now, those are very odd looking, aren't they? But these are some examples of things that are metalloids that follow this same naming. All right, so what's the convention? Greek prefixes are used for the covalent compounds. They're also used for the number of water molecules in a hybrid. So let's go look. So in Greek numbers, we used Roman numerals for transition metal compounds, but Greek prefixes are used, and you're going to remember many of these, all right? For 1, the Greek prefix is mono. All right? For 2, di is the Greek prefix. For 3, tri. All right? Like tricycle with 3 wheels. 4 is, let's go look. And let's talk too about geometric figures are named with Greek prefixes as well, like triangle, 3 sides, pentagon, 5 sides, hexagon, 6 sides, octagon, 8 sides. All right, so Greek prefixes. All right. So we have 5, penta, like pentagon, hexa for 6, hepta for 7, octa for 8, and we've skipped 4. Do you remember talking about carbon tetrachloride? Yes, it's tetra. Like that game Tetris. All right. Mono, di, tri. Tetra, penta, hexa, hepta, octa. All right, so write those down. Now, I'm just going to show you a few of these, and then I'm going to let you do all the rest. So, antimony tribromide, we did that one already. All right? So, what it's telling us is these metalloid compounds are covalent as well. So, antimony, if you look on your periodic table, is Sb. Bromide is Br. All right? Only this says tribromide, meaning this is a very odd looking compound, antimony tribromide, that we've not seen before. All right, we're skipping number 2. Now, these are going to be some oddies, all right? So, chlorine, all right, and dioxide, so O2. This is a very odd compound to us. We would never put these together this way, would we? But the name tells us that this is what the formula is. So, covalent bonds need for their names to tell you the formula. Names tell the formula. Because there's so many possible chlorine and oxygen compounds. Names tell the formula. All right. Hydrogen iodide. I'm going to let you do that one. Iodine pentafluoride. So we have I and Fl. All right, for fluorine. Fluorine is F. All right. So pentafluoride means 5, and if there's nothing in front of the iodine, it means there's just 1. All right? Now, try dinitrogen trioxide. So here we have a Greek prefix before nitrogen and a Greek prefix before oxide. All right, so let's see what you can do. We know there's nitrogen and we know there's oxygen. Give me the correct formula. 15 seconds. N2O3. There are many nitrogen-oxygen compounds, so if this name didn't tell us, we would have no clue. Now, this next guy, ammonia, doesn't have a name that tells you its formula, right? Remember I told you that this name came from the times when the alchemists were doing chemistry, before modern chemistry. So if you recall, this one has the formula NH3. So this is something you have to know by memory, right? Now drew phosphorus triiodide. Does it say there's more than one phosphorus? It doesn't. All right, so we'll put the 2 elements. How many iodides are there? Triiodide, 3. All right, so you have done hydrogen iodide. Now I want you to do all of these. All right, and then I want you to answer that question. Now, in addition, I want us to talk about some things that we're going to do an experiment about a hydrate. So I want to explain what they are. They're compounds that actually suck water out of the air. So when magnesium sulfate sucks water out of the air, it happens to suck 7 of them out for every 1 compound particle. All right? So this would be the name you would suspect, magnesium, SO4 is sulfate, correct? All right, and that little dot means hydrate, that these are associated with, all right, associated with 7 water molecules. So this would be magnesium sulfate. 7 is hepta. hydrate. All right. Now you do the rest of these. All right. I want you to do your best. Answer all of these. Remember, it's important that you do all these assignments because when I come back, do you think that I'm going to be redoing all of this just because you didn't? Yes, you know me well enough to know that I will not be doing that. I'm expecting you to take the initiative and do these. All right. So, have a great day. Finish this worksheet. Adios.